So I'll talk about a subject that you may be heard of it because we talked about it yesterday at the ML workshop if you were here, and Xavier Leroy introduced it a little bit with module aliases. So the problem actually with OCaml is that we cannot link two modules of the same name in the same program. For example, I have a program that has some modules, MISC, AMP, etc. And I use a library, which is lib A. It also has a module MISC, it has a module map, other modules. And I want to compile it. The result is that I cannot because I use two modules with the same name. And actually, it's the problem. So the solution is I can rename my own module. Now I try to compile, and the compiler says that I try to use a module from lib A that uses a module map. I also use a module map, but they don't have the same interface. And actually, I don't have a solution because I want to use the map from the standard library, and the map from lib A is not the one from the standard library. They are not compatible. The solution I have is the obvious one is to ask the developer from lib A to rename its module. It can take some time, but it's the better solution. A really bad idea would be to copy the sources from the standard library map into my program, but you don't want to do that. And finally, I can also abandon the standard library, but I don't want to do that. There are some tricks to avoid those issues. For example, if I ask the developer from lib A to rename its modules, the common practice is using long names. So he will just take its modules and he will prefix them with the name of its library. I will be able to use the library with my program, but the problem is that it can be quite verbose, because if I use many libraries, they will all have long names, and it can be hard to manage. Another practice is using packs. Xavier Leroy talked about it earlier. The packs is simple. The compiler will just take all the compilation units and make a new one that contains all those modules as submodules. For the developer, it is efficient because he won't have to change the code. He will just give options to the compiler. For the user, it's practical since he can distinguish the modules with the path. And since the pack is a module, you can use it as an argument of functor or as a first-order module. It's quite useful. But the problem is that in terms of recompilation, it can be a nightmare, because if the developer uses its own pack, if it changes a module, he will have to recompile the pack, and every module that uses the pack will have to be recompiled. It's not efficient at all. In terms of dependencies, the pack is generated by the compiler, so there is no mention in the sources of the pack, especially when you use the complete path to access modules. And finally, for the executables can be quite large, because if you use only one module, you will have to take all the modules into your executable. For example, if you use core, if it was compiled with packs, the executables will weigh almost 10 megabytes. It's not really efficient. With the new compiler, with the 4.2 version of OCaml, you can use module aliases. So the idea is the developer can just rename its modules by prefixing them and write a wrapper that is only a list of aliases. If he compiles it with the option no alias depth, the idea is that if you don't use the alias, you don't need to link the compilation unit that corresponds to this alias. for the user, it's useful because the executables can be really small, and for the developer, it can be also useful because it can use the short names in its program. For example, here, in its module MISC, the developer can use the aliases that are contained in lib_a. In the second example, the developer uses MISC instead of lib_a.misc, and it works because the wrapper can be compiled before the module it aliases. But in terms of dependencies, it's not really efficient. And as you could see, it looks like there are circularities because the aliases, the wrapper uses the modules, but the modules also use the wrapper. But there is no, in reality, circularity. We can deceive OCaml dep to compute better dependencies. So we can use short names, and the developer can use the namespace transparently using this line of compilation. So the minus open simply opens the wrapper, and you can rename its compilation units with the prefix. But it's not really intuitive. So the current solutions have dependencies issues. As you could see, the build system can be really complex. And one problem is that we don't have extensibility. For example, you maybe want to add modules in a namespace or in a namespace after declaring it. Since we use modules to simulate namespace, it's not possible. Our solution is a real mechanism of namespaces. The idea is every compilation unit belongs to a namespace, and when you want to use modules, you explicitly import them from the namespaces. It's quite similar to the packages from Scala or Java. For example, if the developer from lib_a wants to use namespaces, what he can do is simply at the beginning of each file declaring that the module is in the namespace lib_a. But as I said, we cannot use those modules directly because there are namespaces, so we have to import them. In my program, so I declare that this particular file is in the namespace, my namespace. The second line is simply an import. I import the module MISC from my namespace and the module MISC and map from lib_a. So if I use MISC from lib, if I open MISC, it's the MISC from lib_a. If I declare the empty value, which is map.empty, it's also the map from lib_a. I can try to compile, but once again, it doesn't work because the second MISC I use is the one from my namespace. So I need a mechanism to distinguish them. And actually, we can do that. Well, at the import, we simply alias directly the module into another name, and using the MISC as MISC2 alias, I can use both modules in my program. But it's not really efficient because, for example, if I want to use core and it has been written with namespaces, I maybe want to use all the modules. If I import them one by one, it can be painful. I can simply import all of them using the wildcard. Then, if I use MISC, it's effectively the MISC from lib_a. But, of course, it's not recommended because it will shadow names that are already present in the environment. And it can lead to problems. There may be a solution because we maybe want to import all the modules, but not entirely. For example, I can import all the modules from my namespace, and all the modules from lib_a except MISC. As a result, I can use MISC from my namespace, and the MISC from lib_a is not imported in the environment. There is no dependency of MISC from lib_a, but we still not recommend it because it has the same problem. You maybe shadow some other names. But what happens if I import two modules of the same name in the environment? Here, if the stdlib has been written using namespaces, I import all the modules, and I also import all the modules from lib_a. The compiler just wants me that the module map from lib_a that I just imported will shadow one that I already imported in the environment. It works, but as I said, we don't really recommend to use the OCaml. One feature that is interesting with namespaces is that they are not closed. For example, in Java or Scala, you can add classes in a package afterwards, after declaring the package. Here, I'm writing my own module, and I can declare that it is in the namespace lib_a, but this namespace is used by another developer, an external library. Another extension is that we can extend pervasives to use namespaces. For example, actually with the standard library, pervasives is automatically opened. What we can want is that any module that is named pervasives is automatically opened. So for example, if I use the stdlib right here, I only import the module list, and I use the empty list constructor, which comes from pervasives. What happens is that since there is a module that is named pervasives in the namespace stdlib, I open it. It can lead to some problems because maybe you don't want to open all the pervasives module. So the first solution is simply renaming the pervasives module. So to use directly the path, or simply shadowing it. The namespaces are hierarchical. It can be useful because it's a natural way to organize modules. For example, the stdlib could be organized like this. The OCaml internals would be in a subnamespace named internals, and the module option that you should never use would be in the subnamespace called unsafe. The namespaces are actually directories. First, it's logical because if you want to distinguish two compilation units that have the same name, the only solution is to separate them in different directories. The compiler generates the compilation units in the correct directory, so it's automatic. And using these directories, this schema, we can make, like GHC, an option make that would do the same job as OCaml build to retrieve automatically the compilation units that are needed to compile a program. In terms of dependencies, the namespaces declaration and usage I showed you is actually a header. It only happens at the beginning of the file. So this header declares explicitly all the modules that are used. They can't be sub-modules of others. They are compilation units. You can use OCaml dev to only read this header to retrieve the correct dependencies. The namespaces are some kind of the description of the environment of compilation. At the beginning of the typing, the environment is empty, and each module imported is added to this environment. On the compiler side, this patch is not really invasive. we simply extend the symbols because it's the only way to distinguish two modules at the compilations. And the environment is also extended to use and propagate namespaces to, for example, to normalize paths, etc. If we compare our proposal with modular aliases or other solutions, first we have extensibility, so we can add modules a posteriori. The build system is quite simple. You compile your modules just the way you did before. We don't need special options. We maybe have better dependencies because OCaml dev just needs to read the header. It's more expressive because if you import all the modules, you can hide some modules you don't want. But the problem is that it's a new syntax, so if you use namespaces, any code that you wrote won't be compatible with the old compilers. We have also other work in progress. We are thinking about maybe using the namespaces to generate modules to use, for example, as arguments of functors or first-order modules. It would generate the same kind of wrapper as the module aliases. It would be done automatically by the compiler. Another work in progress is translating big functors into the context of namespaces. So just to remind you, if you haven't heard about it, big functors are packs with functors. It's a previous work from Fabrice. It was for OCaml 3.12. And the idea is, for example, you take co-HTTP. The problem is that it uses we want to use an asynchronous monad, but we don't want to choose. We can use LWT or async. And we use massively functors to have a parametric enough library. The idea of big functors is taking all the modules of a namespace and functorize them automatically by the compiler, so we can declare some kind of parametric namespaces. For now, we're not really sure about the idea. It's really experimental. There are some choices to do, some things to remove, but we think that can be interesting. Finally, the mechanism of namespace I showed you is interesting. It is not intrusive because it's only a header. It can happen. It can only happen at the beginning of the file. It solves compilation issues, especially dependencies and the issues you had with packs or module aliases that can be quite tricky. And we actually have a prototype that works with, of course, many bugs. The syntax is not really clear. The semantics is not really clear. It's actually a proposal. We maybe want some feedbacks if you have any. And if you have any questions, just don't hesitate. Thank you.
So a few thoughts. One is the idea of moving into modules seems like a good one because I feel like part of what you have in the proposal is a language for manipulating modules, kind of deciding parts to include or not include from a module, which I think would be a generally useful thing. I think we run up, like, destructive substitution is already one thing in this vein, and it would be useful to have others. And it would be a shame to go and build this mechanism for namespaces when it would work equally well on modules. So the idea of like converting into modules, doing the transformation after seems appealing. The other thing, the big functor idea, I feel like to me, the biggest difference between what you're proposing and what we already have in module aliases is the openness. And I sort of have 2 points on that. One is, I'd be interested in understanding what the compelling use case for the openness is, because it's kind of not on my personal list of things I really care about. And maybe sort of understand what the kind of key use cases are. And the other is I think there's a very strong tension between openness and functorization. Right? Like it seems very weird to have like a namespace that anyone can join, and when you join, you get implicitly functorized, or don't. Like it sort of feels like the functorization seems like it makes more sense among a closed set of modules than in an open one.
About big functors, the idea would maybe to close the namespace. It's not really what we want to do because the main feature about namespaces is that they are extensible. But as I said, it's really experimental. It's an idea we have. It works on simple cases, and we hope some feedbacks because for example, it could help for Mirage, as they presented how they used functors to be more generic. And with big functors, what we'd like to do is generating the same functors, but automatically.
So big functor seems like a good idea. In some sense, I feel like we're proposing two language features. Like there's already modular aliases, which just give one way of doing hierarchical structure, and now namespaces is another one. And I feel like the idea of piling all the features in namespaces seems like the wrong approach. It seems more principled to say, we'll use namespaces as another way to construct hierarchical modules containing module aliases. And then there's just no reason, I think, to attach the big functor idea to namespaces. That should be attached to just some way of doing this, to some high set of modules. And I think in some of this is mixing ideas that don't need to be mixed.
Interesting proposal, but when it comes to the point where you try to disambiguate which means module you want to access, I really have the feeling that it's kind of ad hoc, and when you, for instance, you rename your means into means 2, so I really have the feeling that what we want here is qualification. Lib a.means, std.means, and things like that. Okay, so I know that it's an addition over the language because you probably don't want simple dot of the modules, but since you are already adding something on top of the language in the header, why not having a qualification inside the files?
Yes, we thought about it. Actually, you already declared the path at the beginning, so we thought it could be not really interesting to use the full path, but we can make it. It's also an idea. I think it's an interesting idea.
So can you go back to a header so I could just remember just one where you've got the header, just to remind me. So because you start with, I can't see it there, you've got like a user or in namespace or whatever bit at the top of the file normally. There we go. So why do you need in namespace if you're already separating them by directory structure? Because I mean, you can see what namespace is going to be implied to the directory.
Actually, using the directory is not enough because you need a way to distinguish the two compilation units to be able to link them. So if you declare the namespace somewhere, you can extend these symbols with the namespace, with the name of the namespace.
Sure, but so if you've got it located in a directory, you could also extend symbols at link time by looking at what directory you're looking it from, and then you wouldn't need to pre-declare the namespace. And so that's my and the other thing, so with all these widths that you're doing here and the various operations you're manipulating, if you did, would it not be simpler to, like you suggest, turn them into modules called module aliases and then use the existing mechanisms we have, like open and rebinding and so forth, to achieve, I mean, essentially the same thing. So I'm not clear on what the benefit is of doing this with a separate language, essentially.
Especially for the dependencies. with the header, you can compute the dependencies.
Yes, but no easier. So your wildcards are basically the same as if you used to use an unspecified open. And I don't. Where you've not used wildcards, a direct alias would be equivalent and just as easy to track for a camel dev, because you can see the directory structure, you see what's a namespace, what's not a namespace. So, that seems like it might be slightly easier to do. And then you don't have this issue of having yet another thing that contains stuff in it. We're going to wrap it up, but 2 modules, one more. I mean, that's 5. Impressive. But yeah, that's just.
I think this is a discussion that should continue. There's more to explain. Thank you again, Pierre.